Hi and good day. I am Jonathan P. Manigo and I will be your instructor for this course. So in this video, I will be introducing our course, Physics 331 Electromagnetism. So for the main details of this course, you have the prerequisite. It's university physics, all of the university physics, and you must also have started your mathematical physics course. You must also have a background in differential equations in your undergrad or master's or even in PhD. You must have already taken differential equation. So the core requisite for this is if you have not yet finished your mathematical physics student, uh, you must enroll a mathematical physics 2 together with this course. So the main reference for this course is the book Introduction to Electrodynamics by David J. Griffiths. I will be using the third edition. If you have a later or much newer edition, then that is fine. So for this course, you need to review this following topics. So you need to review your basic calculus techniques and techniques of differentiation and integration. Your vector calculus that you have learned in Mathematical Physics 1, how to take the divergence of a vector, the curl of a vector, the gradient of the vector, and how to apply the different vector calculus theorems. So you also need to review your different coordinate systems and the different coordinate system transformations. So we'll only focus on Cartesian, spherical, and cylindrical, and the uh, transformation from one of these coordinate systems to the other. The main mathematical tool that you need to master based on your mathematical physics course will be the technique called separation of variables. We will always be using the technique called separation of variables. So you need to also review that one. So there will be 5 main topics for this course, which will correspond to 5 chapters. So the first chapter will be on electrostatics. So we will define electric force, electric field, electric potential, electric energy, potential energy, divergence, and the curl of the electric field. So our progression of the topics will be similar to that of the uh, undergraduate electromagnetism. So start from electrostatics, and then we'll go to magnetostatics. So before we go to uh, electric field uh, interaction with matter, we must first study special techniques on how to solve the electric potential. So once you solve the electric potential V, it's actually a gateway to all of the electrostatic quantities. So if you know V, the electric potential, you can solve for the electric force, electric field, electric potential energy, and so on. So there are different techniques. Of course, one is the separation of variables. We will also introduce the method of images and multipole expansion. And then to finish the topic on electricity, we will try to explore what happens when an electric field interacts with matter. So the answer actually is the matter becomes polarized. So we will try to measure its polarization, and we'll only consider medium or linear media. Uh, when you say linear media, the polarization is directly proportional to the electric field to the power of 1. So that is why it's linear. So we'll only consider those materials or those media. We'll also introduce the concept called electric displacement, which is basically just the electric field in matter. Then we can now go to magnetostatics, wherein we'll discuss in a similar manner. We'll discuss force, field, potential energy, potential, and divergence and current. So if you will notice, electricity and magnetism is an analog of each other, or they mirror each other. Whatever is in electrostatics or in electricity is also found in magnetostatics, except for one thing, which you will discover later. So we'll no longer study special techniques to solve for the magnetic potential, but instead we will go directly to magnetic field in matter. So basically, electrostatics, electric field in matter, magnetostatics, magnetic field in matter. Those are the main topics. So again, similar with electric field in matter, when matter interacts with a magnetic field, the matter becomes magnetized, and we can measure its magnetization. So we'll only still consider linear media, where the magnetization is directly proportional to the magnetic field raised to the power of 1. And we will also, in a similar manner with electric field in matter, we'll discuss or present a concept called auxiliary field, which is just basically the magnetic field in matter. So our classes will have synchronous or live sessions, and this can be done using Google Meet, Facebook Messenger, or Zoom, whichever is convenient for us. So we will usually schedule our synchronous classes on our regular schedule, Saturday 3 p.m. But we can also schedule it on based on your request, on requested schedules. And we will record this so that we can have uh, we can have a record of our class. So most of our classes will be asynchronous. So these will be pre-recorded lectures and in the form of YouTube videos. And these asynchronous video lectures are already found in your LMS Moodle. So all of the lessons are actually now in your LMS Moodle. It's actually complete now. So for the grading system, 15% of your grade will come from your problem sets. 40% will come from the chapter exams. 25% will come from the final comprehensive exam. Uh, we will be having a final comprehensive exam so that when you take the comprehensive exam later, you already have an experience on what to expect in a comprehensive exam in B6331 electromagnetism. The remaining 20% will be on teaching demonstration. So the problem sets or assignments can be scan solutions using Android apps, Cam Scanner, Adobe Scan, etc., depending on you. Or it can also be video solutions. So you can submit the link to your YouTube video solutions to me. So the chapter exams will be written or oral. It depends. So if it's a written exam, you usually just send me your scanned solutions, or if it's an oral exam, it will be a live exam. So it will be a one-on-one oral exam. So for the final comprehensive exam, it is definitely live. So if we are already allowed to have a face-to-face exam, then I'll give you a face-to-face written exam. Or if it is still not possible to have a face-to-face exam, then we'll just do an oral exam, which live oral exam via Google Meet or Zoom. So the last grade category will be the teaching demonstration. So this will be 20% of your grades. So this can be done either live with my own EM electromagnetism undergraduate students, or it can be a pre-recorded video. So it depends on the situation when the time comes for teaching demonstrations. So the passing grade for this course, since this is a doctoral course, the passing grade is 2.0 or better. So you are not allowed to have a grade of 225, 2.5, or 275 or 3 in PhD. So if and that is only for 70% and above. So the passing is 70% and above, and that corresponds to a numerical grade of 2 or better. If your grade falls between 69.99 to 65 or 65 to 69.99, I will be giving you a removal exam, or I will give you a grade of INC if there's no more time for a removal exam. So if you comply, if you pass the removal exam, or if you comply with your INC, then you will get a grade of 2. So if your final grade is 65% or below, your percent grade is 65% and below, uh, it's either failed or dropped or incomplete. So you only have, if the reason why your grade is 65% below is just because you haven't submitted a requirement, then I will just give you a grade of INC, and you need to comply that one within the next semesters. So for more details, refer to the syllabus. So the syllabus is already uploaded in our LMS Moodle. So that is it for the orientation for this course. And in behalf of the physics department and the College of Education, I welcome you to Physics 331 Classical Electromagnetism.